Hello everyone, welcome to TextFire. In today's video, we'll learn about how we can implement document similarity search in SQL Server using cosine similarity. And also, this example will be same for Postgres database. The only difference is the data type is TS vector instead of using this particular DMB to get the indexed keywords from the document. So other than that, everything is same. It's ANSYS SQL, so Postgres will also work. There might be same in MySQL also. I haven't explored, but Postgres implementation is far more superior compared to SQL Server. But still, let me cover this example. It's more easier for me to set up the environment here. So let's start. So I am having one database called, you can say, uh, 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 book summaries, which contains list of books. First two books are duplicate, and this I will be using later in the example. So that's why I made it duplicate. But other than that, most of the books are unique. They have their own summary. So let's assume we want to find out which books are similar to each other so that we can make a decision based, like recommendation decision based on that, like whether to recommend this book to the viewer or not. You can also, there are other use cases also. Let's assume Netflix. Let's say you're running a website like a Netflix and you want to find the movies which have the similar plot and everything. So you can run the similarity search in scripts, or you can just, you can say summary of that movie and see whether to recommend that movie or not. Similarly, let's say you are running a content website or you want to find out whether there are duplicate data in your database. So there are use cases, many use cases which you can use for. So let's just dive into the script first. But okay, before that, don't worry about the script. I have made it available on GitHub, so I will put this link into the description so you can get the script from there. So if you are not familiar much with SQL Server, so in SQL Server to create full text search index, first we need to create a catalog. So if you haven't used full text search, please kindly I recommend at least whatever database like either Postgres or SQL Server, you use full text search to understand that. So and then we create the full text index on the column name description, which is sorry, summary. I think I need to change this one. But so in this particular example, the column name will be summary. So then I had created one book vector table. So now what this book vector table is, it should contains all the documents. So each record is one document. Okay. So all the keywords from each summary it should have. So what I'm doing is I'm trying to retrieve all the document keywords. So let me just run this particular example so that you can get in let me just put star over here. Okay. So here you can see this is giving me document ID, the display term, the indexed term, and a keyword. Keyword is nothing but the hash value, which is more easier in terms of joining and other thing. So this both can be used in place of each other in terms of computation. We have used keywords because it's hash value, so it's faster to compute any arithmetic operation over that. And then it has the occurrence, how many times this word has occurred in that particular document. So first is we are creating this table, and why I'm moving this like output into this particular table, why not directly using it, because it's much faster when it is saved as, you can say, table, because these are DMB, these are executed. So they are the primary motive of DMB is information, not the performance. So they are the generally heavier in terms of performance. So then after that, what I have done is I have just created this particular script. This is very simple script. It is I am implementing cosine similarity. So what I'm doing is first I am you can say ranking the documents based on the keywords, and how I'm doing is because as I said I'm using occurrence as a, you can say, rank, because the number of time, let's say if two keywords have the same occurrence, they should have the same rank. So you can assume in that direction. And then I have created vector A, vector B. This is document one. Sorry, this is document one. This is from document two. So for the keywords, and then I'm creating a, you can say, dot product. It's very simple. You just multiply the rank and sum them, summarize them, and then you have magnitude calculation. Again, rank here is the column. So don't think it as the rank function in SQL Server. So so again, so this is very simple formula. We just compute the cosine similarity, move that into one. So what I've done is once I, so let me just run this particular query so that you can see. So this one gives me the cosine similarity. Now, as I showed you, the first two records are exactly the same. So that's why the similarity is coming one. One means it's they are exactly match. So greater the value from zero, it's that is a similarity. So we can also take some other, you can say, document ID and try to compute the similarity between these, and we'll get the different result. Okay, so it's like you can say it's nearly 5.4% similar to the document. So it's not that much similar to say they both are duplicate or very much similar. So then what I've done is the same query I've just converted into a function so that you can run the similar, you can say, output using a function. And if I just put the value 1, it should give me, let's assume, because it's an exact match, so it might take some time. So the bigger the similarity, it has to do more computation. So once this is done, I have created one computed column in one table called similarity value. It has first document ID, second document ID, and the similarity value. And if I run my query, I will be able to get the similarity. Let's wait. Yeah. So here you can see these two documents are similar. This much percent, like nearly 8% similar. This is nearly 9% similar. And if I just remove the order by, we'll get from the beginning as well. So here you can see we have different order, and also I have not pop, you can say, pushed all the values from the table, because it was the table was around I think 1.5 you can say lakh records. So if I have to create a Cartesian product to compare each one, it was like going in crores. So it was not very good time to spend on an example. So I hope you understand. This is a very simple example. The script is available. Now let's come to the Postgres. Postgres, we have something called as TS vector, which will implement exactly the same, you can say, full text search functionalities. And this is very good because here, let's assume you have some inactive records, so you can just ignore, because you can just not, you can mark their, you can say, full text search value as null, and when they are active again, you can just repopulate it. So it's more easier to manage in Postgres. And then if let's assume your similarity comes same, but still the similarity search are bad because they are keyword based. So if someone just create a dummy keyword based, you can say, information, a long description which contains a similar keyword with a more frequency, it might see them more similar. So the contextual thing, you can again refine it, your output using, because AIDB approach, where the AI model can be tucked with the database directly, or you can clean them from the application side. So it's up to you. So the concept is very simple and it's very easier to implement. I hope you like it. Let me know if there is any question. Thank you.